NASA scientists are telling us that there are more comets that pose impact danger to our Earth than we thought. NASA scientists say the new study proves that there are 7 times as many big and potentially dangerous comets flying through deep space than previously thought. The study analyzed data from the Wide Field Infrared Survey Explorer, WISE for short. This is WISE spacecraft that tracks long-period comets, LPCs, that take at least 200 years to orbit around the Sun. WISE data showed far more LPCs than potentially pose a serious impact risk to our Earth. Previously, the sense was that for every 100 asteroid impacts of full size, we get 1 comet impact. This is what Dr. Joseph Knuth, senior asteroid scientist at NASA's Goddard Space Flight Center, told Daily Caller News Foundation. He says now that we know there are more LPCs for every 100 asteroids, we might get 5 comet impacts instead of 1. Astronomers previously gave broad estimates of the number of LPCs in the solar system. As we said, they're long-period comets, but researchers did not have a good way to detect them since they were obscured by clouds of gas and dust. Gravitational forces can move these long-period comets, LPCs, back into the inner solar system. That's where we have Mercury, Venus, Earth, and Mars. Now, potentially putting them in a collision course with our Earth. An LPC impact would, of course, be devastating. Knuth said a comet impact on average, much more devastating than an asteroid impact because comets are much bigger. Comets are rarer than asteroids but can carry more than 100 times the energy of a typical asteroid. A long-period comet would likely impact Earth at a much higher speed than other space objects. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So they explain that comets are more dangerous than asteroids because they come in to impact Earth at a much higher speed, higher velocity. And Knuth said, and also Paul Chodas, manager of Center for Near-Earth Objects at NASA, said a higher velocity impact would release more energy and therefore would be worse. This is offset somewhat by the fact that comets are less dense than asteroids. The energy release of a comet impact would be less than that of a similarly sized asteroid impact if the velocities were the same. The study also determined that long-period comets, LPCs, are more dangerous than more conventional asteroids or comets because they are twice the size on average. Yes, a body twice the size has 8 times the mass of a smaller body and therefore delivers 8 times the kinetic energy if all other factors are equal. Knuth says the impact energy is proportional to the velocity squared. So a comet moving 3 times the average asteroid velocity would impact with 9 times the energy. Chodas says the potential impact of a long-period comet would be more hazardous than that of a Jupiter family comet, the Taurids as we know, or the Centaurs. The Jupiter family comets, both because the long-period comets are more likely to be larger and because they follow orbits that would impact at higher velocities. The final reason researchers think long-period comets are dangerous is their relative stealthiness compared to other space rocks. Detecting a long-period comet on a collision course with our Earth would be more difficult than spotting a more conventional near-Earth asteroid. Chodas explains the larger distance of comets and the long orbital periods affect the warning time more than higher velocities. The generally larger distance of comets makes the tracking observation less effective since they are angular measurements, and the longer orbital period means that we don't have multiple opportunities to see these objects at closer ranges. The distance at which the comet is discovered depends largely on the activity level of that comet. The difficulties inherent in detecting long-period comets mean that NASA would likely have far less warning that one was coming into a collision course with our Earth. The comet Siding Spring was detected on a trajectory that would strike the planet Mars in October 2014, just 22 months after it was discovered. Since Comet Siding Spring was quite active, it was discovered at a distance of 7 AU, about 2 years before it passed very close to Mars, Jonas explains. Thus, a less active long-period comet might be discovered only a year before entering our inner solar systems. You can imagine how terrible that would be. Establishing a precise trajectory for the comet would be challenging and likely take several months, so the warning time would likely be less than a year. 22 months warning is far less than NASA scientists think they'll need to intercept an incoming comet. The best way to stop an asteroid or a comet from hitting our Earth on such short notice may be to send a spacecraft up to intercept it. But even then, NASA researchers think they would need at least 5 years to construct a reliable spaceship to do that, and man it as well, manned spacecraft, they say here. Now, Knuth says the case of Siding Spring is a reasonable example. Much less than 5 years is a good guess. Siding Spring came in from the celestial pole and was not spotted until it began to exhibit a coma. A large body would show a coma at similar distances. Earth is just as vulnerable to long-period comets and other space rocks as Mars nearly was to the Siding Spring comet. Earth's closer proximity to the Sun would not make it easier to detect a long-period comet on a collision course, according to NASA researchers. The discovery time is dictated mostly by the comet's distance from the Sun and how active the comet is, Chota said. If Comet Siding Spring were heading for an encounter with Earth, its discovery time would be the same. This is on the Daily Caller by Andrew Follett on Bended Reality. Please leave your comments and thank you for your support. Now, just to note that one of the latest comets that hit us was the Clovis comet about 13,000 years ago, the Younger Dryas comet, that impact. And that put an end to the fauna and the flora of northern United States and the Clovis culture. And that was a large comet that cut into 7 large pieces of 1.5 miles each. And they found later on that this comet was fragmented and hit most places around the world. So that's just one of the latest comet impacts. The Clovis comet is the Younger Dryas comet.